Okay, start.
Yes, yes.
Sudhansu, Sahoo, please start your.
Good morning, one and all. Thank you, OMS, for giving me opportunity for this presentation, and congratulations for the 40th annual conference of Odisha Mathematical Society. My paper ID is MDS OMS 47, and my title of the topic is an exploration on computational business analytics practices for decision making. Yeah, in this actually, as business analytics is a infant subject of last 10 years, and it is a mixed research of statistics, data analytics, data mining, and machine learning under the umbrella of data science. So I have gone for one exploratory study of this topic. Actually, we are living in the age of technology, and this has two implications. The first one has it possible to collect huge amounts of data, and the second is implication of technology is that it has given many more people the power and responsibility to analyze data and make decisions on the basis of quantitative analysis. In any organization, the main function of executive is to make decisions, and decision making can be regarded as a problem solving activity yielding solution deemed optimal or at least satisfactory result. Now the organization are overloaded with exponential data, and it's a challenge that with the interference of the human being, the data might be substituted, or there might be a bias due to the human jurisdiction. So now there is a demand of technology which can automate the decision making system and support the decision maker. Now there is a high demand of analytics and business decision making process under the umbrella of data science, popularly known as business analytics. Business analytics uses descriptive, predictive, prescriptive analytics for identifying the insights of data, optimize alternatives, build storytelling to minimize risk and amplify the growth of organization. Now, so far as the descriptive analytics is concerned, it will be describing the nature of the data and the feature of the data. It will portray the characteristics of the data. So as predictive analytics is concerned, it will go for the forecasting, or it will go for inferential statistics. It will draw some conclusion based on the sample. It will go for inductive approach for that. Taking the part of the data, it will be generalizing the whatever result it will be getting. It will be generalizing for the population. Now the population may be realistic, population may be hypothetical. Now question arises, earlier also this approach was there. Then what is the new in business analytics? Business analytics deals with basically hypothetical population. Means if the population is abstract in nature and we are in a prototype stage, then we have only the prototype as a sample in our hand. And by taking that prototype as a sample, we'll be analyzing it, and we'll be whatever result we'll be getting, that we can generalize to that we can do generalize to contribute to the knowledge domain, and it will be helping for decision making. Next comes the prescriptive analytics. Now the descriptive analytics tells what is there, and the predictive analytics tells why it happens. Now the prescriptive analytics will tell what will be happening when the organization is facing this risk. Is there any type of recession in the business organization? Is there any type of threat to the country in future? Is there any type of threat so far as any catastrophe is there? Any type of so far as catastrophe is there? So all these decisions will be done based on optimization theory and simulation. Now optimization theory means operation research and different algorithms, and simulation by using the Monte Carlo simulation method and different probabilistic and stochastic approach. Will be simulating by using different softwares and different probabilistic theory. Now mathematics has a major role in the analysis and decision making so far as effectiveness and efficiency is concerned. Effectiveness means getting the result as it is intended for. Efficiency means by minimum use of resources, how we can get that intended result. So these two are a kind of trade-off. If it will take care of the effectiveness, then it will hamper the efficiency. If it will take care of the efficiency, then it will affect the effectiveness. We will be taking two dimension, one as x-axis as effectiveness, y-axis as efficiency. Then increase in one will give rise to decrease in other. So by this time, there is a need of optimization theory. There is operation research that is there in mathematics. That particular theory will deal with the problem, how the risk can be minimized, how the profit can be maximized, how the return will be maximum. If it is a targeted value, then how the difference between the deadline and the actual value will be decreased by minimizing the residual error. All these are coming under this optimization theory. Now we have gone for the research methodology. Actually, this is a type of research methodology that is exploratory research, a special type of research. If anything is ambiguous, if anything is not clear, if anything there is a dilemma, then exploratory research is taken for clarity of the problem, for clarity of the concept, to either generate a problem or generate a proposition or a hypothesis. So we have gone for one exploratory research, and the design is basically exploratory. That means searching and exploring the peer groups, asking to the expert, taking the help of the guide and the co-authors. We have explored 12 number of papers, research papers. Next is data. The data source is secondary data. As I have mentioned that we have, for this article, we have explored 12 number of research papers. That's why it is secondary in nature. Next comes the findings. Actually, I have shown these findings because at the end I should show, but these findings, what we got, that will make interest to go through the next part of my slides. So here we explored that different mathematical ideas are used in business analytics, modeling, and decision making. Even if the name is business analytics, seems to be business or statistics or data analytics, but actually the core is mathematics. Now, what are the domain of mathematics we'll be going through, that we have already explored and I have cited in my presentation. Also, we have suggested different propositions as an outcome of our exploration. As I have told, that in exploratory analysis, either we'll be landing at a new problem or we'll be suggesting some hypothesis or proposition. So we have proposed 3 propositions in this in our work. Then classification of business analytics, already I have told, descriptive analytics, predictive analytics, and prescriptive analytics in the definition. Then review of literature. Under the review of literature, I have reviewed different. Yes.
Hello.
Yes.
Please conclude your talk. You have just 1 minute left.
Sure. So we have reviewed many branches of mathematics like calculus, linear algebra, basically linear systems, age and values, age and vectors, matrix inverse theory, duality, functional analysis, basically Hilbert space, non-vector space, and Han-Banach theorems, and closed and this particular open mapping and closed graph theorem has is been used by many of the authors. Then probability and statistics, conditional probability, inverse probability, that is Bayes theorem. Then optimization, as I have told, different integer programming, linear fractional programming, non-linear and gradient descent problems. Then data mining techniques, machine learning, evolutionary computations like cellular automata, genetic algorithm, and optimizations, simulations. All these are being used for this business analytics, and these are the 3 propositions we have proposed. The first one, 43% of that particular 12 number of journals we have reviewed, 43% of the people are intending to ask this particular proposition, that in real-time sensor data collection through IoT and recursive algorithm can accelerate the business analytic decision. Second one is noisy data and subjectivity by human judgment should be reduced to enhance the effectiveness and efficiency by business analytics. Third one is business analytics is less dependent on domain knowledge and more on big data analytics. So no need to afraid of the domain. We can apply business analytics to medical science even if we have no knowledge of medical science. We can apply to business finance even if we have no knowledge of finance. No problem. Data will give the information. And these are the references, the 12 journals I have referred. Any question, please?
Any questions? Okay, thank you.
Thank you.